Deep shaft construction is often complicated by challenging geological conditions such as high groundwater pressure and alternating layers of hard and soft soils. To address these, shaft sinking increasingly avoids traditional dewatering techniques to prevent ground settlement, which can impact a large area. The heron-necked vertical shaft sinking machine, VSM technology, provides a solution, allowing shafts to be constructed safely, quickly, and economically in difficult ground conditions, even within limited urban spaces. The shaft sinking process begins with the excavation of an initial section, typically 1-2 meters deep, where a concrete ring beam is installed to provide foundational support and guide the sinking process. The first shaft segments are then assembled and lowered into place, with the bottom segment featuring a reinforced steel cutting edge. This edge functions as a cutting knife, allowing the shaft to sink efficiently. Strand jacks are placed on the ring beam, with steel wires attached to pockets on the cutting edge. The number of strands matches the total shaft weight, creating a stable suspension system. Preparation for the VSM installation continues by positioning brackets for the machine arms using a dummy frame. The machine is assembled to match the shaft's diameter, then lowered into place via a mobile crane and attached to the brackets. Additional equipment, including winches, power supply lines, and communication links, are installed to provide full control and maintenance access. The surface control unit displays data from the excavation, giving the operator precise control over the machine's position and actions. The cutter boom, which can operate manually or automatically, excavates the shaft profile as needed. To balance surrounding groundwater pressure, the shaft remains filled with water, which also serves as a transport medium for excavated material. The VSM's telescopic cutter arm rotates from the center outward, adaptable to shaft diameters between 4.5 and 18 meters, and able to function in water depths of up to 80 meters. In soft soils, the cutting edge continues to shape the excavation as the shaft sinks. When encountering hard soil or rock, the VSM can lower within its bracket, extending the reach of the cutter boom to maintain a consistent profile. In challenging conditions like sticky soils, a high-pressure cleaning line removes debris from the cutter drum. Excavated material is transported to the surface through a slurry circuit, where separation equipment processes it based on local soil conditions. As the shaft advances, precast concrete segments with rubber seals are bolted to the upper shaft structure, allowing continuous excavation and construction of new segments. Segment sizes and materials can be customized, with in-situ concrete forms used for monolithic lining if the shaft will later house tunneling equipment. A bentonite lubrication system further reduces friction between the shaft exterior and the surrounding soil, with nozzles tailored to match soil types. Once the shaft reaches its final depth, the VSM is removed and a concrete base is cast. Bentonite around the shaft is displaced by grout injected through the nozzles, sealing and stabilizing the shaft. After the grout hardens, water is pumped out, and the shaft is completed without affecting groundwater levels or surrounding soil stability. To date, heron-necked VSM technology has been used for ventilation and emergency shafts, storage facilities, tunneling launch and reception shafts, and other underground applications. Its compact design, speed, and adaptability make it ideal for urban and environmental requirements. Heron-necked continues to innovate VSM technology, expanding applications while prioritizing safety and eco-friendliness in all projects. Traffic jams on the motorway do more than just waste time. They inflict significant economic losses by stalling logistical processes and preventing people from getting to work. Addressing this, the Astra Bridge project was developed, partly supported by state funding, to keep traffic flowing safely and efficiently on the motorway itself. The Astra Bridge, engineering innovation at scale. The Astra Bridge is an impressive mobile bridge measuring 257 meters, 843.2 feet in length and weighing 1,250 metric tons. Its modular design allows it to follow curves with a 1,000-meter radius, achieved by fabricating the bridge in sections. Each segment can be steered up to 3 degrees at its joints, providing the flexibility to adapt to road curvature. Swift assembly, completed in just 2 nights. Due to its modular construction, the Astra Bridge was assembled on-site in just 2 consecutive nights. This swift deployment was possible because of its innovative structure, which includes 18 gantries and 4 ramp units, each self-propelled by radio control. While cranes were only necessary for positioning the ramps and the 19 intermediate segments between gantries, the rest of the assembly relied on the bridge's own power, enabling quick positioning and setup. Night 1. Initial bridge assembly. The first night saw 2 assembly teams working simultaneously from opposite ends of the bridge. They began by positioning the ramp tips on the road and connecting the 4 ramp halves to these tips using powerful short-stroke presses. Once secured, a mobile crane positioned a central segment with coupling bolts, which allowed the first gantry to perform a 90-degree rotation and dock onto the bolts. Intermediate decks were then placed on either side of this structure. At the close of the first night, the 2 halves of the bridge met and were coupled together, creating a functional 136-meter, 446-foot bridge, including 2 68-meter ramps for entry and exit. This allowed traffic to begin flowing over the bridge immediately.
Zürcher Strasse, noch ein Zürcher Strasse. Das kommt gut. Garten, jawohl. Gut, ist gut.
The train is down.
Night 2. Completing the structure. On the second night, crews delivered the remaining gantries and intermediate decks, adding the final 100 meters of the bridge. To install these additional sections, the previously assembled bridge was uncoupled and opened, allowing workers to complete the structure. Once the segments were in place, the entire bridge was recoupled and manually shifted to the designated section where the motorway surface needed renewal. All 22 gantries were then linked through a master-slave program for synchronized movement. The final Astra Bridge is a striking feat of engineering. Length 257 meters, 843.2 feet. Width 7.57 meters, 24.8 feet. Height 4.65 meters, 15.3 feet. This mobile bridge not only demonstrates remarkable adaptability and efficiency, but also reinforces the importance of keeping traffic on the motorway, providing a safer, streamlined solution for infrastructure maintenance and repair. Since early April 2024, the innovative Astra Bridge, a mobile construction site bridge, has been back in operation on the A1 highway heading towards Zurich. This state-of-the-art temporary bridge allows vital roadwork to take place beneath it, while traffic flows smoothly on top. Construction crews are making steady progress on the resurfacing and structural enhancements below the bridge deck, all without interrupting traffic. Drivers traveling above the construction zone benefit from 2 open lanes, allowing for safe and steady travel at a regulated speed of 60 kilometers per hour. This setup not only maintains the usual traffic flow, but also minimizes congestion and maximizes worker safety, showcasing a clever solution for infrastructure upgrades in high-traffic areas. Asphalt reconstruction is a meticulous process of rejuvenating worn or damaged pavement, involving the removal of deteriorated layers and the installation of fresh, resilient asphalt. Small damaged spots may just need patching, but larger areas require full reconstruction to ensure longevity and quality. This process, while complex, has the precision of an art form, resulting in roads and parking lots that are both durable and visually appealing. Step 1. Milling. The asphalt cheese grater. The journey begins with a milling machine, a massive device resembling a cheese grater on wheels, which grinds away the damaged upper layer of asphalt. This initial step strips away uneven sections, damaged patches, and surface imperfections, leaving a rough but prepared layer beneath. A sealing coat is often applied next, ensuring a clean, secure base for the new asphalt to adhere to. Step 2. Recycling the old asphalt. Rather than sending the milled asphalt to a landfill, it's transported to a recycling facility where it's processed, cleaned, and refined. These recycled bits often become part of new asphalt mixes, reducing environmental impact and creating a sustainable loop. This clever recycling process not only conserves resources, but also helps manage costs by reusing high-quality materials. Step 3. Preparing the foundation. Crack repair and leveling. After milling, the underlying layer is evaluated. Any cracks, dips, or weak spots are either filled or repaired, ensuring a solid foundation. Contractors use crack fillers and trowels to mend these imperfections. To create a seamless bond between the old and new layers, bitumen joint tape, a stretchy, durable material, is applied along the edges at an impressive rate of 15 meters per minute. Step. A tack coat, a sticky adhesive layer, is applied over the repaired foundation to bond the new asphalt layer firmly to the old one. Applied with a blower and squeegee, this layer is essential in creating a unified surface that will withstand heavy use and varying weather conditions. Step 5. Laying down the new asphalt. The asphalt paver at work. Now comes the heavy machinery. A paver loads new asphalt from a dump truck or material transfer unit into its hopper, sending it down a conveyor belt to an auger, which spreads it evenly across the surface. The screed, an extension that smooths and flattens the asphalt, hovers just above the ground, providing initial compaction. The screed's angle, weight, and vibration are precisely calibrated to create a smooth, uniform layer. Modern pavers are equipped with automatic screed controls that adjust on the fly based on sensor readings, fine-tuning slope, elevation, and thickness. Material transfer units are used to deliver a steady asphalt flow, preventing bumps and dips and ensuring a consistent surface, which is crucial for the paver's speed and the thickness of the final mat. Step 6, compaction. Setting the foundation in stone. The finishing touch is compaction, done by rollers that compress the asphalt to remove air pockets and solidify the surface. Roller trucks ranging from 3 to 10 tons move over the freshly laid asphalt, creating a compact, durable pavement layer that can withstand years of traffic and weather. This step, much like tamping down the foundation before building a house, is essential to the durability of the surface. Step 7, pavement marking, finishing with the perfect touch. Finally, clear, precise pavement markings and lines are painted to define parking spaces, lanes, and directional guides. This final touch creates an organized, professional appearance that's both practical and welcoming for drivers. Clear markings are especially valuable in parking lots with larger vehicles like SUVs, helping guide traffic and avoid congestion. Why quality asphalt reconstruction matters. Beyond aesthetics, a well-paved surface reduces vehicle wear and accident risk while making parking lots and roads more accessible and user-friendly. Properly prepared asphalt minimizes reflective cracking, where old cracks resurface in new layers, often leading to rapid deterioration if not addressed. Building on a strong foundation and using high-quality materials ensures that the investment in asphalt will stand the test of time, enhancing property value and reducing long-term maintenance costs. In short, quality asphalt reconstruction is as much about preparation as it is about the final result. Each layer and step has its purpose, from recycling to foundation work, resulting in a smooth, reliable, and sustainable surface. With every element considered, from durability to visual appeal, asphalt paving transforms from a quick fix to a lasting solution.